Well, congratulations. I believe it's time to celebrate. You've just finished your first project, code ready. It's time to start the deployment exercise. So where do we go? Of course, to the cloud. And what better cloud than that of Azure? It's a bright place. We start off by simply logging into the portal and, well, wait a minute, that's a little bit overwhelming. I need to think. I need to think a lot. Going to spend some hours researching, figuring it out, and then we get our first server online. But then one server, that's not really going to do much for me, is it? So I'll probably need to deploy a few more. For example, I'm going to want a high availability or run in special locations. That implies I need a load balancer to spread the load across those servers. And then of course a database to store all my data. And we're going to have some files uploaded by our users. Need to store those as well. I have to be aware that everything is working correctly, so let's enable some monitoring, some application insights. And then of course we need to send the traffic, so we got to build some networks, subnets, routing tables, gateways, and maybe even connections back on premise. We want everybody to be able to find their services on the internet, so let's add on another piece, some DNS. Of course, we don't really want our secrets leaked, so we'll store away our certificates, we'll enable transport level security, and we'll put all of our passwords and keys, connection strings, and the likes into a good strong key vault. And when we've all of that done, we realize that that's just a staging environment. Now let's repeat it. Let's do it all over again, but this time in production. We've got DevOps tools, lots of them. So we get to choose, do we want to use Azure ARM, Ansible, Docker? Are we working in Windows or on Bash? What tooling are we using for automating this? Azure DevOps, Travis CI, Circle CI, Jenkins? And then of course we have monitoring, so that we're aware when stuff actually doesn't work. And, well, it gets a little bit overwhelming. And before long, what was an easy thing, it's not so easy anymore. And the good news is, you get to maintain this all forever. So let's start. We're going to start with the confession. And the confession is, while DevOps is really good at getting things done in the application world, DevOps really is still stuck in the Stone Ages. Let's be honest. Most people are telling us we need to deliver the most advanced, cool technology on the planet. But when you sit back and start looking at the tools that we have to make this happen, it feels an awful like we're using a lot of duct tape, a little bit of sellotape, some super glue, a band-aid, and all of these other things to try and make this work. But that can't be right. You just need to sit for a moment, read the blogs, the headlines, listen to everybody that's speaking at presentations, and everybody's working on the cutting edge. Kubernetes, Docker, serverless, microservices, infrastructure as code, it goes on and on and on. How do people get time to do all of this? Where do we start? Where do we finish? Where's next? Are we done yet? But it doesn't really feel like cutting edge. The reality is when you wrap your head around a lot of these things, it feels an awful lot more like we're doing a lot of makeshift stuff. So here's something that we don't admit to. Building production-grade infrastructure is actually hard. And it's stressful. And it takes a whole lot of time. But there is one trend I like. Managing all of this as code. At least as much of it that is physically possible. Provisioning, configuration, application settings, building, deploying, testing, schemas, and documentation. All of these things, we want to get these wrapped into code so that we can essentially repeat the processes. And why? Because we get all of the beautiful benefits of code. Automation, versioning, reviewing with our peers, testing to make sure that what we have actually works, documentation that is real, up to date, true, and tested. And of course, the icing on the cake, we get to reuse this stuff over and over. So, where do we start? We create a reusable library of infrastructure as code. Now, why? If we do that, we can take a look at our normal approach of building something like a managed service, wrapping that into infrastructure as code, maybe 1 to 2 weeks, assuming you've learned the basics of how to write infrastructure as code. You want to get a little bit more complicated and put in a stateless application on top of that infrastructure, because after all, that infrastructure is not a whole lot of value without an application. So let's double that. Now we need 2 to 4 weeks. Of course, as you start scaling across your regions and your data centers, you want to have some stateful information. We're going to put in data into our databases or into our storage accounts. This thing gets complicated fast. Now we're looking at a 2 to 4 month period in order to make this stuff happen. And then the utopian, we want to have everything that we deploy, our entire cloud architecture, fully infrastructure as code. Well, let's be honest. All of these things need to happen in series, or if they're going to happen in parallel, we're going to need a lot more resources to make it happen. So this can be anything from 6 to 24 months, or depending on the size of your environment or your organization, it could be a whole lot longer. But we do want to make a change. We want to figure out how can we pull all of these things down to a single day. In this discussion, I'm going to share with you what I've learned as we have embraced the concepts of embracing infrastructure as code for our solutions, our partners, and hopefully for you. Ladies and gentlemen, good afternoon, good morning, good evening, depending on where you are in the world. My name is Damian Flynn. I'm speaking to you from the west coast of Ireland, and I am a Microsoft's Azure MVP and a Cisco champion. I work for a consulting company based out of the Nordics called InnoFactor, and I am today going to speak with you around lessons learned on building enterprise-ready modular infrastructure as code. Are you ready? Let's start. Right, so what I'm going to share with you is 5 major points that we've come across as being part of our best practices to be successful as we've written lots and lots of infrastructure code. The first one is a checklist. Second, the tools that we've settled on using. 3, I'm going to talk at depth about modularization and why it's important. Then we'll talk a look at something that's not normal practice with infrastructure code, and that is the concept of testing. And in the end, how we can release this to our users, our customers, and internally for actual consumption of the efforts that we've put together. So let's begin with a checklist. Now, what is the checklist and why do I need it? Well, one of the big reasons that we're trying to do this is that we can reduce the amount of level of effort and time necessary to deliver our services. We're suggesting that, for example, we can deliver a managed service in 1 to 2 weeks, or an entire cloud architecture in 6 months for a small organization, or 24 months, best hope, for a large enterprise. And that, of course, depends on the complexity of the environment. But how is it possible that it's going to take that length of time? Because we've all read the blog posts and we've seen the methodologies people walk through suggest that this is actually pretty simple. And at the end of that blog post is, we've celebrated the fact that we have delivered a fantastic infrastructure as code. What they haven't told you is the level of effort, the times that's been spent on fixing and redoing to make all of this work. So how can I stand or sit and speak to you guys and suggest that this is going to take 6 to 24 months to wrap up your environment? Well, there's 2 main reasons. And the first reason is yak shaving. Yak shaving? I'm assuming you know what that means. Well, if not, let's explain what yak shaving is. It's a seemingly endless series of small tasks that you have to do before you could actually do what you set out to do originally. An excellent overview of that is from Seth, where he basically talked about waking up one morning and deciding it's time to go out and wax my car. He heads downstairs, takes a look, grabs the hose and realizes the hose is broken. Then best thing to do is run down as far as the local hardware shop and grab a new one. But the hardware shop was in the far side of town, and in order to get there you're going to have to pass some toll bridges. The neighbour has an EasyPass card, so let me run in and grab that. When he heads in, he realizes, oh, hang on a second, my son has a Mushi pillow that we borrowed from the neighbour, and he's not going to give me that EasyPass until he gets back the Musi pillar. So I run in and I go search and I find that Musi pillar, only to find that the stuffing has fall out of it, which of course I need to get new yak here to restuff it with. So before I know it, instead of waxing my car, I'm sitting in the zoo shaving a yak so that I can finish the job I started off to do. Now the other problem is that the checklist is actually a long checklist, because we're here for a reason. We're going to bet our organization and our services on this infrastructure that we're about to play. So it's not that short. In order to deliver production grade infrastructure, we need to address a number of major elements. And at this stage, I've got that list down as far as 12 major items. We want to cover the installation, obviously, to install our software dependencies. Want to configure it to make sure that obviously the paths and the ports, connection strings, they're all working. I've got to provision the software, make sure the infrastructure, the load balancer, networks and everything is put into place. And then of course, the obvious ones where we're going to roll out the service and make sure we've got our canary deployments or our blue, green and everything is working fine. So no major rocket science. These are the typical things we'd want to do as we start an infrastructure as code project. But then if we think about this from the concept of the IT pro, then we'd also want to be thinking about things like security, making sure, for example, that we're doing proper authentication, we're doing encryption, both in transit and at rest, making sure that we're hiding our secrets and that we're hardening our environment. No point putting this thing into production if I can't monitor it. So we'd want to make sure that we're both monitoring the application stack and the application layer, the hardware infrastructure that is hosting this application stack, so that we understand exactly what's happening, both the servers, the applications, what events are coming in, can I trace, can I get alerting? And then we talk about the logs. Let's, for example, assume that we're deploying something like a database. We're putting it on a virtual machine. Then we'd want to make sure we're rotating those logs, because the worst thing we could do is let that hard disk fill up. Then we've got a systems down. We also want to make sure that our logs are sitting in a central location so we can do aggregation across them and intelligence across multiple logs. And of course, none of this has any value to me if I have a failure. So I want to make sure that we're doing backups of both the VMs and our databases, because losing one of these systems could be the equivalent of losing our business. Our data is our business. Then things get even a little more complicated, because we then need to think about the fact that, well, there is plumbing. We want to make sure that we have our network set up with all of the subnets, the IPs, the firewalls, DNS names, aliases, routing, and of course, everything that happens on the network layer, we also need to log. Then make that a little bit more complicated. This is no value to me if that piece of infrastructure has just failed because I only deployed one virtual machine or one instance. So I'd want to think about making multiple instances. Or maybe what happens if the data center fails? Maybe I want to contemplate things like availability zones or regions. So high availability needs to be included in our architecture. And of course, we're looking at being successful and taking advantage of the fact that we're sitting in the cloud. So we talk about scalability. Scaling out horizontally if we're running an infrastructure type solution where we want to just simply add more servers, or worse, scaling up vertically, changing the size of services we're running on and making them actually larger servers. Again, part of our designs should be the monitors to trigger such an activity for scaling up, and of course, there's no point scaling up if I don't shrink back down. And then the really hard stuff comes. We want to think about optimizing, making sure that the system is running very efficiently, that we're not using super large hardware where we don't need to, making sure we have the correct type of disks, that the performance is right. If we're running specific applications that have performance metrics that need to be tuned, let's say they're Java-based applications, then it's really important to do benchmarking, load testing, and profiling. And this job alone, that's 5 or 6 months just to get some of our infrastructure sorted out. And after we've done all of this, we didn't need to take a look at, well, how much is this actually costing me? Am I losing money by doing all of this? So I want to actually optimize the infrastructure costs so that when we set up this environment, we get all of the above at an affordable price. And then when we're really content that everything makes sense and we're ready to share this and show it off to everybody, of course, the first question back is, well, where's the documentation? What are the architecture decisions you've made? How do things pull together? What practices have you implemented? And finally, probably the most understated a lot of this, is that everything that's part of this environment needs to be tested. Tested rigorously to make sure that everything works as expected. So the checklist is long. There's a lot of different things that we need to check, and not every single thing on this list needs to be deployed for every piece of infrastructure modules we write. We pick, we choose, and we make decisions saying this is or it is not applicable for the particular modules we're writing. But we do make notes and we document that decision to say we're making it. So the key takeaway is that in order to use this, we should have a checklist to build production-grade infrastructure. Now, the second topic that we want to talk about is tooling. What are the tools that we use to implement all of these fantastic things that we've got in our checklist? Now, tools are a method to an end. We need to define the infrastructure that we're deploying. We need to make sure that everything we're using is going to be maintained and popular so that it's easy to get people that are used to leveraging and working with these tools, can learn how to use them and get the documentation. That the ability to reuse the infrastructure we write or compose it into new models, that we don't need additional infrastructure support in order just to run infrastructure, because that becomes redundant costs, and we need to be able to implement immutable infrastructure. We update and redeploy because our objective here, of course, is fast deployments with very little to no downtime. Now, the choice of tools utterly depends on what you want to do and how you do it. For our infrastructure as code, we focus specifically on core tools like Microsoft's Visual Studio as our editor of choice. And of course, we're using the ARM client and Azure's own JSON definition for ARM templates. For in-guest configurations, we're using, again, native tooling and following through desired state configurations. But this is not really about what tools to use. Those choices are absolutely yours, depending on the infrastructure you're deploying, the technology you're using, and what best fits your organization. But what's important is that the tools that you do select at this point adjust and fit the objectives that you have to hand. But tools are not enough. We actually need to change behavior too. So let me explain that for a moment. If we think about the old way we do things, we would have logged onto the system, made changes directly and manually. It didn't matter if it's production or staging or a test environment, the behavior was essentially the same. And our new methodology is that we should make changes indirectly and automatically, which really implies that we don't touch the end system. Instead, we touch the infrastructure code, and that infrastructure code then gets taken over by something like Azure, which reads the code and updates our system. However, learning how to do this JSON definition and talk to Azure with this language and get flow, this takes time. It takes practice. And more time than actually doing this thing by hand. And if you think about the fact that we may have had an issue, then sometimes time is not available to us. And if that's the case, those changes are going to be made manually. And if they are made manually, then the infrastructure code that we have is of no value, because the next person that actually is following the proper behaviors or the proper tasks is now making changes in an environment that actually is no longer reflected. So we've broken our process by the fact that we've had a time pressure or we haven't understood the decisions we're making. So up front, our decision process to do infrastructure as code has to be lined with the fact that we now acknowledge that everything we're about to do from this point forward is going to take longer than it did previously, because I should not be making a direct connect, go in and make a tweak. Instead, I should be following my indirect methodology. So as a result of this failing back, we have this problem of not being able to scale, because everybody's making changes to an environment. We can't redeploy it. We have nothing to reference upon. The only way forward for us is essentially teach the team, invest the time, and run infrastructure in code where we can have it implemented and interpreted directly to the final destination. This is the only thing that scales, because then we can take advantage of the team, do the code reviews, and follow all of the normal best practices that we as a development team can focus on. So your key takeaways on this scenario is that tools on their own are not enough. You must also change our internal behavior to make sure that we do not break glass. Now the next topic is modularization. And this one is an interesting one, because all of the documentation you're going to find, all of the sample codes that are posted by Microsoft on their quick start templates, all of the blog posts you're going to read, they are all going to follow the same behavior. Attempting to define all of our infrastructure codes in one file or one folder. And that could be made 10 times worse, because we may not just have all of the infrastructure, but we may have all of the environments for that infrastructure in one file. Development, QA, testing, staging, production, which lends to us having a file that's executing very slow, really hard to navigate and understand, teach people how to work with. Code reviews are near impossible to complete. Testing, because it is one ubiquitous file, means we're going to test every single piece of infrastructure. That might be from a database to a DNS entry to an access control rule. There's no reuse. Absolutely no reuse, because you're effectively defining your infrastructure for a solution in one single file. And of course, to deploy this, because this file has to have access to all of these artifacts, you simply give it the keys of the kingdom and deliver it permissions at the administrative level. And of course, the concurrency of how many people can test and work and deploy on this is limited to just one person, because there is no way for us to essentially share that infrastructure. So one single mistake in this file, anywhere in this file, is going to break everything in the environment. There is no doubt about this. So in essence, we will treat and consider large modules of infrastructure as toxic and harmful. They are fine to get the concepts of samples to grab out of, but that's where it ends. This is not production class infrastructure. And that's also why, if you take a look at any of the blogs people are sharing, they are talking about, here's an example of how to do this, but don't run it in your environment. Microsoft called their Azure templates quick start templates, because they're exactly that. It's an example of how to take 5 or 6 different modules, put them in the correct dependencies order, and essentially get you a proof of concept into place. They are not production grade infrastructure. Just consider the checklist we looked at earlier. How many of the boxes do you think those templates check? Very, very few. Most likely the first 4. The other 12 will be left out. So what do we really want to do? We want to build our infrastructure as is isolated. For example, development, test, production, different code bases for each one of these. You also want to go a step further. You want to actually separate the modules. Let's drill this thing in properly so that we end up with an actual module that implements a firewall or a virtual machine. But think about that for a moment. Is that not how the cloud already works? When I go to the portal and ask to deploy a virtual machine, don't I just get a virtual machine? Well, no, I don't just get a virtual machine. I get a virtual machine. I get a disk. I get a storage account. Some of those are managed on my behalf, so I don't see some of that magic. I get a network interface. I might get an access control group. I also may make some decisions that I need to actually add some extensions into my virtual machine. So every one of these are separate modules. So resources inside Azure need to be grouped. And we group those down into the module size that makes sense for our organization, for your infrastructure as code. So our virtual machine might not be just the virtual machine, the disk, and the network interface. It might also be every virtual machine we deploy has one network interface, has two disks, one for the operating system, one for the data. It also has an extension for antivirus, an extension for monitoring, an extension for application insights. All of these extra things become part of your basics. You also may make some decisions saying not only do all of these things need to exist, I also have a requirement that the disks are sitting on encrypted storage and that the operating system is using BitLocker type technologies so that the environment is always built to my best practices for my enterprise. That becomes my infrastructure module. That's what we're going to build as our component when we build infrastructure. So if we take our architecture, then all we need to do is split it up into smaller parts. Every single element in our infrastructure simply becomes a separate module, and inside that module we can then define, test, and work on each piece. And should we decide later on that we want to change the composition, use a different service or resource, maybe change the firewall from being a network virtual appliance that we've purchased in from companies like Cisco, Palo Alto, Barracuda, and swap that out and use something native like the Azure firewall, then we're just modifying or creating a new module. We'll follow our checklist through, and then as we compose our infrastructure, we're simply calling the module that matters to us at that point in time. So how does all of this look? Well, let's take a look at that for a moment. Here we're looking at a copy of Visual Studio Code, my preferred editor for actually creating my infrastructure code. And on my navigation plane, I can actually see a list of my modules. Now every module is essentially stored in a separate folder, so I've put a naming standard around these to keep things consistent and easy, and each folder will contain no less than 3 main artifacts. First artifact is the documentation, which defines what we're doing with this particular module. We talk about how we compose the module, what are the arguments we pass in, are they mandatory or optional, and if there are defaults coded into place. We also look at the reference. What are the outputs that come from that particular module? Where are they used for? And a description for that. In addition, if these references need additional explanation, we include that in our documentation. And of course, no documentation is valuable unless we can get to a point where we can actually test it, run it through a scenario, and check to see if it works. So in order to do the testing, we're going to leverage tools like Pester, Microsoft's native toolkit built on top of PowerShell. We'll talk a little bit more about this in a few moments, but in essence, we can run through the scenarios of essentially establishing infrastructure, picking a resource group, and then taking that particular module and deploying it, knowing that that deployment has either successfully passed or failed allows us then to make some decisions to say this module is no longer good or longer bad. And of course, the module itself follows the standard consistencies that we see in all modules offered for Azure, and that includes the main key areas of the schema definition, the version of the content, the parameter sets that we pass in, any variables that we want to establish based on the parameters or other logic, resources that we're going to actually implement and deploy. I have the options to add an extra section called functions, where I can actually have reusable functions that I may use in my code. And then, of course, as things are completed, I may deliver you back out some outputs to say, this is the results of the efforts we've made, the resources we deployed, for example, a public IP, this is the IP address, or here is the reference to that IP address, because I may need to use that in a later module, for example, associate a public IP address with a network interface that might be in turn associated to a virtual machine. And each module that we build follows exactly the same behaviors. So it doesn't matter if that module happens to be deploying security key vaults, firewalls, policies, all of these things are defined and referenced directly within the code. So with an idea of what our modules look like, everything is small, easily configurable, making it quite easy for us to start the concepts of reusing, making these things multiple process. Because if I can multi-purpose these, then it's easy for me to take my picture and change it. Drop off one module and replace it in another module. So a key takeaway is that infrastructure should never be built toxic. We should never treat quick start templates as production grade templates. We should never, ever deploy environments that are not built in a modular approach. So let's talk a little bit about testing, because as we build modular services, we've got to make sure these things work. And testing infrastructure doesn't really happen too often. Infrastructure code rots very, very quickly. But it doesn't have to. Infrastructure code that doesn't use automated testing, I think, is much better defined as broken. Now, why would I say something like that? Well, let's think about this for a moment. If we're writing general purpose languages, Bash, Python, C#, you name it, your choice, then we will run unit tests on all of these, and we'll generally run a lot of these unit tests directly on our local computer. We do our normal developments, put our unit test cases and everything into place. But if you try to do the same for an infrastructure code, well, you can't. There is no local host. I don't have an Azure sitting on my laptop, or maybe I'm not lucky enough to have an Azure Stack sitting in my data center. And even if I did have an Azure Stack running in my data center, it's only a subset of that public cloud. So all of the resources I'm trying to test and validate, I can't. In order to test infrastructure code, I really need to go directly to that infrastructure. So I don't have a lot of choices. I have to deploy real infrastructure. I have to validate that that deployment works, just like I showed you in that pester file. We need to run the deployment. We need to make sure that all of the resources that we expected to be deployed are deployed. And of course, we need to clean up after ourselves. After we've done that deployment, we need to actually tear it down, get rid of it again, because it's of no value other than validating that this infrastructure code is correct. But if I wrote that code once and I've tested it, then why would I want to do this again and again? Doesn't take a genius to figure out we're living in the world of cloud. Nothing stays stagnant. And even in the concepts of Azure, that could never be more true. Infrastructure code is just like any other microservice or any other application. It is written to an API, a specification. The specification that we're working on is a JSON specification to define how we want to write our resources. Those APIs are versioned normally as a year, so 2015-08-01. The most current API releases is 2018-12-01. And what's different between these versions? Obviously, different feature sets have got turned on in the cloud. But with everything that gets turned on, things get changed, or worse, things get deprecated. So if you've written infrastructure code a year ago, there's no guarantee that while it was working perfectly a year ago, that is going to work tomorrow morning, because maybe the API you're referencing has been deprecated, or maybe the parameters that are expected are no longer valid, or maybe that service doesn't even exist anymore. So we need to validate that the modular code that we have is not rotten. We want to make sure that it is not broken. So how do we do infrastructure? Well, let's talk a little bit about some of the ways we've learned best to do infrastructure code. Using the tooling inside Azure DevOps, we first start with keeping all of our code sitting inside the Git repositories, keeping track of all of the changes that are happening and using these changes to trigger essentially pipelines. These pipelines are then responsible for building our different infrastructure and making sure that that build process helps us every single point to validate that everything that we're doing actually works. Now, there are multiple steps that are involved in that, and that might be as simply as running something like a lint across the JSON to make sure that it's running correctly, connecting into Azure, copying up our templates to a blob, and effectively running our tests. Now, these tests are, as we've looked at in our code, the responsibility of actually deploying the environment. So if we take a closer look at some of these things, we put together support mechanisms, allowing us to authenticate us to where we need to get to. Running the pester tests, finding every test XML file result and putting them in a central location so we can take a look at how those successfully or unsuccessfully completed their exercises. The reason that we go through this level of effort is that we do not want one developer working on the code. We need a team of developers. And we want teams of developers to be able to work on multiple modules or the same module simultaneously. So following the normal branching processes inside our repository, each of these developers can work confidently that the changes they're making and validating in their environment is not going to break the release mechanisms, because everybody is running in their own branch. And as they get ready to pull their code and their module changes back into the central environment, as they push their code back up, we kick off a test pass. We'll test based on all of the modules that these guys have written. But beyond that, we also actually run some tests to make sure that the combination of modules, that composition, that we're not breaking it as well. So inside every one of these, we have the idea of deploying something as simple as a public IP, or something a little bit more, a public IP with some storage. And again, following the same idea, I keep my tests, my documentation, all in the same place, the same set of artifacts. And as I look at the templates that we're deploying, I can see that I'm referencing the specific templates that I care about. So in this particular case, I'm going to call my module, which is my naming standard. I'll follow that module with a public IP, and I'll follow that module with my storage. So I have this ability to do modular development, but more importantly, as we merge these branches back together, if a change made on any one of these modules breaks any of the composition samples, then we immediately know that we have to stop and fix this before we can merge. And sometimes that means updating the sample. And we can go a step further. We can also make a decision saying, well, let's look at some reference architectures, things like virtual data centers, STRIs and SSH/RDP gateways, or something as simple as a Guacamole VPN type service. All of these are complex environments using not just the modules that we're using for building our infrastructure, including again our naming standard, our storage, our virtual machines, but also inside those virtual machines, we need to actually run install scripts to check and make sure that everything that is necessary to finish completing the configuration for our server are all intact and in place as well. Only by implementing proper testing to all of these different tiers can we have any level of confidence that our infrastructure code is not broken. So let's talk about one or two simple tips. First tip, every single infrastructure should be deployed into completely separate sandboxes. Clean testing, clean deployments every time. And a second tip, test, create, and destroy lots of resources, but some tests fail. Make sure that we go back and clean up any leftover resources, or we'll end up with a big mess, which will be links to a credit card, and that's going to make things even nastier. The testing pyramid. As developers, this is second nature. Unit testing, integration testing, and end-to-end testing. And as we move up to the pyramid, tests get more expensive, brittle, and harder. But how does this pyramid work with infrastructure? Well, unit tests for infrastructure tests the small submodules. We've just seen that in the code base and in the repository. Integration tests validate things like our samples, making sure that multiple different combinations or compositions of these modules all work correctly. And then end-to-end takes that stack, takes that reference architecture, the virtual data center, the Streisand, the guacamole servers, and ensures that these environments deploy end-to-end. Now, one thing that's probably important here is that these things take time. A unit test for a module, depending on the module, for example, if it's an Azure web application gateway, that could take 45 minutes because that gateway takes 40 minutes alone to deploy. Now, if that's a unit test, that's not so bad, but if that's an integration test, then the period of time for that test running takes much longer. And end to end, if I'm deploying a full data center and may have multiple firewalls and multiple application gateways, then we appreciate that a period of time for a test pass to execute is not trivial. That needs to be taken into account. So the final key takeaway for this section is infrastructure without automated testing should always be considered broken. It is a point-in-time function and is only valid at that single point in time. We seriously recommend that you run your tests every time you make a change and every night you run in end-to-end to validate that while your code may not have made any change, the target you are hitting, the cloud, in this case Azure, it is. And you need to be aware of those changes so that when you come to rely or to be dependent on a module, that you are aware that that module is in effect still of value. So we've got to the end of the exercise. We've figured out how to actually get our code modularized. We've looked at the process around testing. All that's left for us now is essentially to pull it all together. We need to release this. So to do that, we really want to just reflect on the process. We need to take the tools, the checklists, and the modules and make sure that every single time that we prepare to create a new module that is going to be production ready, that we look at that checklist. We look at all of those different artifacts and elements in the checklist and make a very conscious decision of what we will and will not include and why we are making those decisions. Do I need to make a backup of a public IP address? Possibly not. Do I need to log who's utilizing that public IP address? Quite possibly. So we checklist that, we document that as part of our process. With a checklist agreed and the architecture talked about, we can then move on to the next phase. We can write the code. We pull together, following our modular approach, all of the different pieces of the modules that are necessary for us to go ahead and build our first pieces of infrastructure as code. Then, with that, we're going to write our pester tests or whatever tooling you decide to use for your environment. If you're using Terraform, then you'll use Terratest. If you're using ARM templates, you may use the Azure CLI, you may use Azure PowerShell. The choosing tools is irrelevant. The important point is you must test. When we've completed the testing, we also get the ability to do code reviews. We can sit with our partners, review the infrastructure that they've deployed, the decisions they've made, and understand exactly what's going on. Something that we could never really do in a normal infrastructure project because there was no code. We are now on a code-based approach. And as a result of that, we can then make a call to say that the infrastructure that we have at this point in time is solid, it is tested, it hasn't rotten, and is built on the best practices with the documentation to support it. We can now release that version to our users internally and to our customers externally. And far more importantly, we can safely take that and deploy it, promote the environment that we have already instantiated to production level. So the final takeaway is infrastructure as code is not easy. It's hard. It's very hard. And quick start templates are not production ready templates. The journey is fun, the journey is hard, but the journey is well and truly worth it. If you need additional help in starting your journey to infrastructure as code, want to take advantage of some of the modules, the time and the effort my team and I have put into building reusable infrastructure as code for building technologies like virtual data centers or application solutions and reuse some of the composability, then please feel free to reach out. Or if you've any questions and queries on how to actually validate your pipelines and understand how best to embrace infrastructure as code on the Azure pipeline for enterprises, I'm happy to help. My name is Damian Flynn, and thank you for joining in on today's Best Practices with Azure Infrastructure as Code.